Hi, greetings to the panel. IR Awam bin Taib and IR Nikmat bin Udin. I'm Muvieanraj Anantakumar, here to present my final year project supervised by TS Dr. Muvieanraj. The title of my project is The Effectiveness of Residual Slope Reinforcement Technique in Increasing Shear Strength Between the Soil and Plant Roots. I've divided my presentation into three main parts. The first one is before the project starts, which means general information about the project like aims, objective, and literature review has been presented in that part. Secondly is the findings of the project throughout the methodology that carried out. And lastly, the conclusion of the project that was derived from the findings of the project. Starting from the background of the study, right? Landslide at slopes are very common during rainy seasons. This happens because studies and researchers has proven the pore water pressure increases within the soil and roots. So that is the reason why it's happening landslides during rainy season. Therefore, it is necessary to implement techniques that moderate or decrease pore water pressure within the soil. So that is a random article taken from a newspaper that has been cited in my slides, as the panels can see. As for the problem statement that I've written here, cement manufacturing produces 8% of global greenhouse gas emissions. And I think, as everyone knows, cement become one of the pioneer required raw material that is used widely in constructions. So cement production is the third largest industrial source of pollution, emitting more than 500 tons of gas emissions, gases like sulfur dioxide, nitrogen dioxide, carbon monoxide after oil and gas and the change of land industry. Relating this and landslides at slopes, the project proposes a greener solution. So relating the background of study and the problem statement of the project, I was able to find out the main aim and objectives of this project, which are the overall aim is that to improve the stability of residual slope in Gambang by increasing the factor of safety of the slope. And the specific objectives are to measure the soil properties of Gambang residual soil so that we can determine what are the required tests to be performed to find out the factor of safety of the slope. And secondly, to measure the shear strength of soil with and without the roots of Eugenia olaina and Dicrapnotris linearis. So Eugenia olaina is well known as pokok kelapaya, and Dicrapnotris linearis is well known as pokok resam. And the last objective is to calculate the factor of safety of slope reinforced with plants to differentiate how effective the plant roots that are planted in the slopes itself. And I believe it is my responsibility to clarify the scope and limitation of the project. So the scope of this project is to identify the effectiveness of plant roots at slope as a reinforcement in Gambang residual soil. And this method is more suitable to slopes that are along the walkways and highways. So the limitation of this particular project is that the bioencourage technique is not applicable to very steep slopes. To be even more specific, it's not applicable to any slopes that are more than 25-degree angle. And this method is not to replace the conventional method of slope reinforcement, for example, like anchor bolt or retaining wall, because I believe plants can enhance the stability of a particular slope, but not as much as a rock solid concrete structure can do. So these are the limitations of the project. So for the literature review part, there were several journals read and researched and used for my thesis writing, as well as for the this presentation. So these are examples that I can put in the slides, or that I can show to the panels that I used for my research. So just a quick recap of all these three journals is that they have found out that the roots actually enhances the shear strength of the soil. There were a lot more journal papers that I used for this project. So moving on to the research methodology. So the project location is exactly located at FCASA, next to Survey Lab. FCASA stands for Civil Engineering Faculty building in UMPSA Gambang campus. And all the tests were performed at Soil Mechanics Geotechnical Lab, except for the test of FISM with EDX, which was performed by professionals in Central Lab of UMP. So these are the experiments list. I've done sieve analysis at the berg limits, hydrometer, or better known as fine analysis, moisture content, particle density, unconfined compressive strength test, direct shear box test, and fissile bit EDX. So as the panels can see, this is the flow chart of my project. And finally, I have to explain about the experiments that I've conducted. I mean, the main 3 experiments that I've conducted to derive a conclusion to answer my objectives. So the first one is fissile bit EDX. So it literally means enlarged image of the plant roots. So the plant roots were bisected, and to identify their age group, which I'll explain later in the result and findings part. So secondly is that direct shear box test, shear strength of soil, specifically cohesion, the C value, and the angle of friction value was found out through the direct shear box test. And lastly, unconfined compressive strength, to measure the maximum axial compressive stress that a particular soil can handle with and without the plant roots of pokok kelapaya and pokok resam. Now let's move on to the result and analysis part. So this is the most important part of my presentation. So these are my findings through the laboratory tests that I've conducted. So firstly, the soil classification process, I think it is the most essential whenever it comes to any project that involves soil, because right after we identify what type of soil that we are handling with, we can plan on the test that we are supposed to do to get the particular parameters to answer my objectives. So as the panels can see, these are the findings. So according to ASTM, according to USCS, the soil sample can be classified as SP, or in another word, I can say poorly graded sand. So this is the output from the mechanical analysis, or better known as SIF analysis, and hydrometer test, or better known as fine analysis. So the second part of soil classification process was to identify the liquid limit, the plastic limit of the soil. So from those information, I was able to derive that the soil sample collected can be classified as poorly graded sand with silt. Why I say so silt? Because the plasticity index comes less than 7%, making it to be silt with a degree of plasticity of low plasticity, and it is partly cohesive. So since it is partly cohesive, that is the reason why the unconfined compressive strength test and direct shear box test both was conducted through the project. So here comes the next experiment. Right after the soil classification analysis, we were able to derive it as poorly graded sand with silt. Basically, the roots were differentiated, segregated in terms of their age, or in a better way, I can say in terms of their maturity. Like we had like younger plants and matured plants to differentiate the effectiveness of that plants in that particular slope. So this is one of the experiment to identify the maturity or the drastic differences both the roots of the plants have. So as the first picture shows, it is a roots bisection of Eugenia olaina, or as I mentioned earlier, pokok kelapaya. So as the panels can see in the pictures, it has very drastic differences can be spotted in the growth of xylem, basically the small tiny holes that we can see, which help to differentiate the maturity of the plant of the root. So the left hand side picture shows the younger plant, and the right hand side shows the matured plant. But the case is not similar for the pokok resam, where both younger and mature plants seems to have the same size of xylems. Therefore, other parameters like I mentioned earlier, diameter, leaves color, so the total thickness of the roots were used to differentiate the maturity of the plants. So these researchers used 4 different types of plants, which belongs to 2 type of species of the plants, and I think that's very clear to the panels to understand the differences between the samples. So nextly, moving on to the UCS test, which is also the unconfined compressive strength test. So as the panels can see in the slides, it is very clearly stated, or can be very clearly seen that the raw sample, which is the first slide on the left, shows that 206.09 kilopascal, which is the unrooted soil, compared to the other 4 samples, which are the samples of pokok resam and pokok kelap paya infused with the soil and then tested with the testing machine, and they produced a better peak strength respectively for all type of samples with roots. So what we can derive from these findings is that from the obtained result, the matured pokok resam or Dicrapnothrix linearis could withstand the highest compressive strength, which is about 263.32 kilopascal. So nextly, here comes the last experiment that I've performed for my project, which is the direct shear box test. So basically, this direct shear box test was done under two conditions of soil. Firstly is the dry sample, which means oven-dried sample, and wet sample. Wet sample means the dry sample was then added with optimum moisture content of 17.62%, which was the similar water percentage used for our UCS test previously. So now at the end of this direct shear box test, the yellow color indicates the highest value of shear strength recorded. So it is very clearly stated that dry sample for the dry sample, for the dry condition of soil, it seems to be the peak strength was for the dry soil meaning that soil without roots. There were no roots present in the sample, and it attained to be to have the most highest shear strength compared to other samples. But the scenario is not same for the wet samples, whereas clearly we can see that wet samples, especially for the sample with smaller version of Kelat Paya or a younger version of Eugenia olaina, has recorded the highest shear strength for all three types of weights or loads imposed. So basically 136.2 refers to 5 kgs, and 272.5 kilopascal refers to 10 kgs, and 400.5 kilopascal refers to 10 kg. So as the load increases, the shear strength increases as well for the same type of samples. So I think from overall from this test we can conclude that when a soil is wet or the pore water pressure increases within the soil, somehow the roots comes into play to stabilize the slope. So as a conclusion, we can say that three main parameters were obtained from this test. They are cohesion, friction angle, and shear strength. So unrooted soil recorded the highest shear strength, as I stated, for dry condition, and younger Eugenia olaina recorded the highest shear strength for wet condition of the soil. So this is the last part of the project, is to generate or to calculate the factor of safety. So these two tables represents the values or the numerical values that has been used into the formula that I will present in a while to calculate the factor of safety. So basically all the parameters were obtained from the test except for the slope angle, gamma saturated, and gamma prime, and also for the WV. So these four parameters were taken from previous studies, whereas the angle of friction and cohesion was tabulated from the laboratory test performed by myself. So moving on to the factor of safety, this is the formula used to calculate the factor of safety, and the table here shows the factor of safety calculated for dry and wet condition. So in this case, the M stands for matured, EO stands for Eugenia olaina, Y stands for younger, and DL stands for Dicrapnothrix, or well known as the pokok resam, as I mentioned earlier. So from the results of a factor of safety, it is very crystal clear. There is a very drastic difference between the factor of safety of the slope, where we can see in both conditions, dry and wet, even though the plant roots were able to generate higher shear strength, whenever it comes to the factor of safety, the unrooted soil has the highest factor of safety in both wet and dry condition. So finally, in conclusion, the research on slope reinforcement using bio-anchorage technique might increase the shear strength of the soil, but the influence of roots on cohesion and friction angle might make the slope unsafe, producing a lower factor of safety for both the plant types as shown previously. Although the rooted samples shown an increase in cohesion and shear strength and also the compressive strength through the UCS test, the attained level falls short of providing genuine stability for the slope, as the saturation level of soil varies according to the climate, meaning that if it rains more, the saturation of the soil will increase. So therefore, we have arrived to the final part of my presentation. What I would suggest to the upcoming somebody or who's interested to do the project related to my topic, I would suggest that uh, it is way better and it is definitely recommended to use undisturbed sample, because in my project I've used all disturbed samples to get the parameters that I've obtained. So I would definitely recommend somebody else who's interested to do this topic to seek for the undisturbed sample, so that we can get a better parameters value, which might generate a better factor of safety. Also, to mention that all three objectives were accomplished at the end of the project. The first objective was to classify the type of soil. The second objective is to measure the shear strength of soil with and without the plant roots. And the third objective was to generate factor of safety with and without the roots. So at the end of the research, all three objectives were accomplished. So that's all from me. Thanks for listening and thanks for the opportunity, and thank you so much.